Right, let's dive straight into this explainer. If you're aiming for top marks in IGCSE Physics 0625, mastering these core concepts is an absolute must. We're talking solid friction, drag forces, circular motion. This stuff literally appears in every single examination series. So if you want to secure those top marks, you really can't afford to leave any gaps in your theoretical architecture. Let's strip away all the fluff and look at exactly what the examiners are actually demanding from you. Okay, look at the sheer contrast on this slide. It is night and day. On the left, we've got a painful, flawed 2 out of 10 answer that completely lacks context and shows zero working. Stuff like that is a massive grade boundary risk. But on the right, that's a beautiful 9 out of 10 top band answer. It's got crystal clear working, exact terminology, systematic processing, the whole shebang. Today, we're going to reverse engineer this perfect answer so you can stop losing marks to ineffective revision strategies. Section 1. Core Physics Principles, the Theoretical Architecture. Let's build that foundation. Let's kick things off with solid friction. Now, the basic definition is pretty straightforward, right? It's just the resistance to motion between two solid surfaces interacting with each other. But Cambridge examiners emphasize something much deeper here. Top-performing students don't just memorize definitions. They show a connected, conceptual understanding of this principle. They know exactly how friction integrates with other areas of the syllabus, like energy transfers and kinematics, and they can apply that understanding to totally unfamiliar contexts. And that brilliantly illustrates our next point on drag forces. We're moving from solids into fluids here. Drag forces are simply the resistance encountered by objects moving through liquids and gases, with air resistance being your classic example. The principal examiner reports consistently tell us that candidates who point out cross-topic connections, like, say, linking drag forces to terminal velocity for falling objects, they achieve significantly higher marks. It's all about seeing the entire physics ecosystem, not just isolated definitions. Finally, let's look at circular motion. The absolutely crucial point here is the precise causal relationship. Circular motion is movement along a circular path caused by a force acting perpendicular to the direction of motion. That one word, perpendicular, is literally the linchpin. It's a tiny detail that catches out so many students year after year. Understanding that the force acts at a right angle to the velocity is the exact kind of conceptual mastery the assessment objectives are targeting. Okay, so we've laid the groundwork, but I've got a secret to share. In just a bit, I'm going to show you the one specific examiner clue that changes your answer completely. If you miss it, honestly, your perfect physics knowledge won't save your grade. But first, to make that clue blindingly obvious to you, we need to set up the technical framework to apply it. Section 2. The technical methodology. Deconstruct, solve, and evaluate. By following these exact 5 steps, you're guaranteeing that your processing is systematic and perfectly aligned with the grading rubric. First up, you deconstruct the question to identify the key elements. Second, you extract the relevant data from the texts or tables. Third, select your analytical framework or the relevant principles. Fourth, execute your analysis with incredibly clear notation. And fifth, verify your results and present them in the proper format. This is exactly how you tackle complex physics texts or datasets without getting totally overwhelmed. Now, when you're actually sitting there structuring your written response, you want to map it directly to this progression. You start with the concept, anchoring your answer in the core physics principle. Then introduce the evidence or data you extracted from the prompt. Next, apply your scientific reasoning to build a logical bridge between that data and the concept. And finally, you cap it off with the exact examiner wording, using the precise terminology the mark scheme demands. This 4-step architecture is virtually bulletproof. But hey, what happens if you just completely mess up a calculation? Well, take a close look at this quote from the examiner alert. It highlights the method mark strategy and states it explicitly. Even if your final answer is wrong, method marks can save you. Students constantly throw away marks simply because they don't show they're working. You absolutely must execute your analysis with clear working every single time, because Cambridge awards marks for the process itself, not just your final destination. Section 3. Examiner warnings. The top 3 exam mistakes. These pitfalls are incredibly practical and you need to watch out for them. Number 1, forgetting to use the proper format in friction and circular motion problems. Number 2, poor checking of that format and overall presentation. And number 3, which is arguably the most fatal of them all, providing generic answers that aren't specific to the context given in the question. Failing to apply the specific context or ignoring your presentation format will instantly drag a top-tier answer right down into the failing bands. Section 4, Interactive Viewer Challenge, Spot the Error. Let's see if you can think like an examiner. Take a really close look at this statement about circular motion. The object stays in a circular path because of a force acting parallel to its motion. Ask yourself, what crucial theoretical principle is completely messed up here? Take a second. Predict the correct answer based on the definitions we covered just a few minutes ago. Did you catch it? If you notice that the force has to be perpendicular rather than parallel, you hit the nail on the head. You're thinking exactly like a Cambridge examiner. This brilliantly illustrates how just a single word can completely destroy the scientific reasoning of your entire answer. Remember, circular motion is fundamentally driven by a force acting perpendicular to the velocity of the object, no exceptions. Beyond just getting those facts right, true problem solving uses a continuous deconstruct, solve, and evaluate loop. To really lock in those top band evaluation marks, you have to push past the obvious. You need to explicitly state the limitations of an experiment, point out the assumptions made in your evidence, or offer alternative interpretations of the data. Checking for reasonableness and making justified recommendations, that is exactly what separates an average student from a top-performing one. Section 5. The missing link, command words. This is the massive trap I warned you about earlier. So here is the harsh reality. You could have the most perfect framework in the world, but it means absolutely nothing if you misinterpret the specific command words that dictate the mark band of the question. Whether an examiner tells you to explain, describe, calculate, or evaluate, each of those words demands a completely different application of our framework. If you just describe when you're supposed to explain, your perfect physics knowledge is totally wasted and you are going to lose those marks. Your ability to actually deliver that 9 out of 10 answer depends entirely on what you do next. To make sure you know exactly how to decode these command words, hit subscribe for Ace the Exams at acetheexams_IGCSE. But I want to leave you with this thought right now. If your exam was tomorrow, would your perfect physics knowledge be completely wasted just because you described instead of explained? We'll close that gap next time, so I'll see you in the next explainer.